Man, I am so excited for this video. Aren't you? Triangles? I mean, oh man. Well, you're probably not very excited because triangles, they're not exciting. But I am super excited because triangles suck. There is nothing in mathematics worse than a triangle, and there is nothing more extensively studied in mathematics than a triangle. A triangle you'll learn all the way from geometry up through trigonometry, and I mean, you'll spend entire years over the triangle. I mean, literally, trigonometry stands for math triangle. I mean, triangle. I'm super excited that I get to introduce you to this idea that will haunt you forever. Aren't you excited? Anyway, moving on. There's 3 types of triangles. Bam! Isn't that crazy how it just changed? Anyway, as I was saying earlier, there's 3 types of triangles. The first one is an equilateral. Now, the part that you want to remember is this, equal. Kind of sounds like equal. It looks a lot like it too. But what an equilateral triangle is all 3 sides are the exact same and all 3 angles are the exact same. Because there's really 2 ways of categorizing a triangle. There's categorizing it by the angles, and there's categorizing it by the sides. An equilateral is unique because it has all the sides are the same and all of the angles are the same. Now, all of the angles, each one of these little angles is going to be 60 degrees for it to be an equilateral. Why it has to be 60 degrees is for every triangle, the inside angles have to add up to be 180 degrees. Now, 60 plus 60 plus 60 equals 180 degrees. The second is an isosceles. Never mind. I'm not going to try to spell that. An isosceles triangle is interesting because only 2 angles and sides are alike. Now, this is some pretty funny annotations. It's a thing in geometry. It's a way to mark similarities. But the important thing to remember is for an isosceles triangle, 2 sides are going to be the same, and 2 angles are going to be the same. If only 2. Now, it has to be both of these. It can't just be like the 2 sides are the same or 2 of the angles are the same. It has to literally be both to be an isosceles triangle. Now, the last type of triangle is kind of the funny one. It's called a scalene. Scalene is just a weird name, isn't it? Scalene is a triangle that is not equilateral or isosceles. A scalene triangle, best described, is a triangle that has no equal values in either the lengths of the sides or the measurements of the angles. So each one of these angles is going to be different. Now, the thing that's interesting is there's a special type of triangle that can be either isosceles or scalene, and that's going to be a right triangle. For example, this right triangle that I drew, this is isosceles, because I've got both of these angles here that are the same and both of these lengths here that are the same. But at the same time, you can have a scalene triangle, a scalene right triangle, to where this is 90 degrees, and that's what classifies a right triangle. So this is 90 degrees, and this could be 25 degrees, and this could be another unique number, and these 3 sides are all going to be different, so that it's a scalene. Now, it's incredibly important to remember, though, that the isosceles triangle, the equilateral triangle, and the scalene triangle are all determined off of the length of the sides and their angle measurements. Yeah. Now, a couple things you want to know. The perimeter of a triangle is simply the addition of all 3 sides. So, say this is 2, 3, and 5. Your perimeter is going to be 7, 8, 9, 10. Is going to be 10. You just add up the sides, and that's your perimeter. Your area, though, is 1/2 base times height. Now, let me scroll down real quick. How do we know that? Well, simply A for area equals 1/2 BH. Generally, the ACT isn't going to make you do too much work on this, except for trigonometry, except for the trigonometry part. It'll generally give you this dotted line. Now, this dotted line is going to have a measurement, and if not, you can pretty easily find it through trigonometry. But all you take is 1/2 times both height, and then that answer times base. So you get 1/2 base times height. I'm not going to provide you with an example because really this is one of the most simple equations you'll ever have from here on out. So you should be able to figure this out. I mean, that's a little bit frank and maybe a little bit rude, but if you can't, find a way how. Now, one thing that you're going to definitely want to know for both geometry, trigonometry, and the ACT are side lengths and equation. Now, to find the side lengths of a right triangle, let's just make a quick, poorly drawn right triangle. You'll have your 90 degree, your angle theta, your angle funny x thingy, and then you'll have sides A, B, and C. Now this is only for a right triangle. You use what's called the Pythagorean theorem. Well, what's the Pythagorean theorem? We've all probably heard of it, but the Pythagorean theorem is a squared plus b squared equals c squared. Believe me, you will need to know this. This is incredibly important, all the way up through trigonometry that I know for certain. Now, a squared plus b squared equals c squared. Well, what's an example for that? Because this actually can be pretty confusing. Let's say we have c and we have 3 and 4. How do we find c? Well, you simply take 3 squared plus 4 squared equals c squared. Now, what you do is you can just go ahead and drop this c squared down into the next equation. You're going to want to square both of these, so you end up with 9 plus 16. You add those together and you get 25 equals c squared. Well, we just want to know what c is. So you just take the square root, and 25 squared equals 5. So you end up with sides length 3, 4, and 5. And ironically enough, this is called a Pythagorean triple, 3, 4, and 5. There's only a couple numbers like this, but that's not too wildly important. This is going to be incredibly important. You're going to want to definitely know how to be able to do the Pythagorean theorem, what it is, which is simply a squared plus b squared equals c squared, and how to utilize it. There's a couple other ways to utilize it algebraically, which you're going to have to be able to figure out on your own. Sometimes it'll only give you sides b and c, and you'll have to figure out what a is. You're going to have to be able to figure that out on your own algebraically. And if you can't, find out how. It's pretty simple, and you can come talk to me, you can talk to Mr. Hemphill, you can talk to anybody in NHS, and we'll all be able and willing to help you figure that out. Now, the third thing I want to go over today is called special triangles. Oh, they're so special. They're just special triangles. But with a special triangle, there's two types. There's the 30, 60, 90, and the 45, 45, 90. Whew, man, that's a lot to remember. Don't worry. I will write it down, and so will you. Write this down. Make sure you do. 30, 60, 90. Now, this poorly drawn triangle, I might add, is going to be our 30, 60, 90. Now, the special triangle, okay, here, so we've got, and let's say that's 60 degrees, and this is 30 degrees. Now, what's unique about the special triangles is the Pythagorean theorem will work, but we have easy, quick solutions that can work as well. They're not going to be easy and quick if you don't write this down, though. You have to make sure you write down exactly what I'm going to say from here on out. Okay? Okay, good. Now, the way we can do this is simply x times square root of 3 and 2x. how these fit together or how somebody ever came up with these, honestly, I will never, ever know. It is totally beyond me. Now, this works though. It does. Let's show algebraically that it actually works with the Pythagorean theorem to come out perfectly. So this way, with a 30, 60, 90, you only have to know one side to know all three. Let's say we take a squared, which would be x squared, plus b squared, which would be x squared 3 squared equals c squared, which would be 4x squared. Now, we already know that this will end up being x squared plus 3, because the square root and the x cancel out, 3x squared. So x squared plus 3x squared equals, and we can already tell that it's going to work, because 3 plus, well, this could be 1, since there's nothing standing in there. 3 plus 1 equals 4, and you just keep the x squared. So it obviously does work. It's just how somebody ever came up with it is totally beyond me. Your other special triangle is going to be 45, 45, 90. Now this one is much, much easier to remember. The 45, 45, 90 is a unique kind of isosceles triangle. It's the only isosceles right triangle you'll ever see. So we have 45 here and 45 here. Now, this is x and x, and this is x square root 2. Now, the reason why these two are the exact same is because the angle is the exact same. You'll learn more about this in trigonometry, but with how this angle here corresponds with the side across from it. This angle corresponds with the side across from that. So the 45-degree angle causes this length, and the 45-degree angle is going to cause the exact same length since they're the same degree. But if that doesn't suit your needs, we can also show this with the Pythagorean theorem. X squared plus x squared equals x square root of 2. 2 squared. Now, x times square root of 2 squared is just going to end up being 2x squared. So we have x squared. We'd have 2x squared if you add... Oh, excuse me. We would have 2x squared if you add both of these together. And with this being squared, you would end up having 2x squared. So we show that with the Pythagorean theorem, these work too. Now, I just want to give you another heads up. Triangles are literally the entire class of trigonometry. And that's not a bad thing. It is a lot of variation to them, and you learn a lot that's very useful. It's also a part of calculus, and I guarantee you this will be on the ACT. So if you haven't been paying attention, go back and rewind the video. This is incredibly important, and it will be on your ACT. You must know how to do this. And if any of this doesn't make sense, please either come to me or come to Mr. Hemphill, or go to Miss Tresh. She knows all of this by heart. Or anybody who you know can understand this and further explain it to you. Until next time.